So, let's implement a memory game. So I have this little snippet that I made on CodePen. So this is gonna be our card. So we're gonna use little emojis, and we have this little card. And I have two different classes for this card. I have solved and unsolved. So an unsolved card, when you turn it, when it's over, looks like this.
You're using those CSS backgrounds.
I am, and I'm using emoji characters for the content of the card. Right, so here's what a card looks like when it's unsolved. Right, here's what it looks like when it's solved. The back will look like this. And we also have a flipped class. Right, that will just flip the card over to whatever its back is, whether it's solved or unsolved. Right? It's all done with CSS. Toggling the classes is done with JavaScript, but the rest is just done with CSS. So I love playing with this stuff in CodePen because I don't have to have a whole app. I can just save it on CodePen. A little snippet of HTML. It's not even a full page, right? Just a couple divs. I can make some CSS and a little bit of JavaScript, right? And I can work on this and say, okay, well, this is what my cards are gonna look like. So let's make the memory game. Create React app, Reactified memory. So we're gonna make this memory game, and we're gonna do the classic thing. We're gonna design it first, and then we're going to let's make it static, and then let's slowly make it dynamic. So wait, when we do that, we find a list of mdfind is a command line version of Spotlight. So you can Spotlight. So Jason has this nice array of Nope. He has a nice array of symbols. So we're going to grab these because I like these. So I want those in my app. Let's bring up Adam.
How do you submit new emojis?
There's a committee that decides on what the emojis are. It's part of the W3C, I believe. So let's build out our static app. So I'm gonna, since I like these emojis he had in his app. Take my focus. Let's paste. So these are all the different emojis we're gonna use in our app, right? For our little memory game. Holy smokes! Thank you, Prettier. Oh my god, okay, well, it's not bad. So, here we go. Yeah. So, let's start designing out the game. Yeah, that's cool. So, let's grab a couple of these cards. So, here's my card. And let's we're just going to paste in a couple of these cards from here. We're going to grab our CSS, and we're going to put that in here. So our app, let's see what our app looks like. Okay, cool. Here's our cards. Let's make them unflipped. There's one of them unflipped, right? And then let's grab a couple different symbols. Let's give it skull and crossbones. Not yet. I always want to start out doing things hard-coded. Right? I want to start out hard-coded because I just want to prove to myself, let's grab the donut, yeah, that I can make this work. Donut and whatever that is. Let's copy that. Now let's put it down here. Let's remove foot from each of these. Cool. Right, so here's our game. Let's put a div around this with a class name of the board. Around all these divs. Oh, I did? Thank you. I didn't need to do that. Cool. Here's our board. Can we make this a UL? Make this an LI. Now that we have a list of them, I think it makes more sense to make these LIs and LIs. I think we're going to lose some of our styling. No, we didn't. Awesome. So let's say all ULs are list style none. Let's make the board display flex. And let's do justify content. See what space around looks like. Cool. Let's put a header in here. Cool. I'm not going to go much further with styling than this. Cool.
So that box will just take up whatever screen size is. So you put like 15 more cards on them.
Yeah. So remember, it's going to keep putting them out this way. So let's take this card and put a whole bunch of them. All right. So what do we want to do? Yeah. Let's make flex wrap. And then on the card, let's give it some margin of like 2 rem. Maybe 1 rem. That's too much. Yeah, that's not bad. Press her down here. So we're working on these widths and heights. Maybe, yes. So maybe instead of the margin being rems, let's make it like a quarter of the height. No, let's make it like 1/10 the height. Cool. Okay, so here's our memory game. Let's commit this to our static implementation. So let's add some state to record what's in the memory game. All right, so I want to represent each of these choices here as part of my state. All right, I don't want to hard code popcorn, donut, person taking bath. Right, I want to drive this in state. So I'm going to make a state. And we'll say this dot state equals, and let's call these what? Cards. And it's going to be an array of Oops. It's going to be what? It's going to be an array of popcorn. So these Unicodes are kind of tough sometimes to copy and paste. There we go. Popcorn, and then what's next? A donut. Nope. I got the donut there. The donut. And then finally, what? The person in the bath. So let's make too much in here. I've got a little. Right. So rather than having this be this. Hmm? And then repeat for the rest of these. I'm going to get rid of the repeats here. I don't feel like doing all of them. Cool. Right. So now if we replace, right, the donut with an X, right, we just get an X. Right. So now I'm driving my static representation with state that's not dynamic yet. Driving static UI from state, not yet dynamic. Cool. So, right, now we have these repeated, right? Let's make a card component so we don't have to repeat that. Let's make card.js. Let's make a default component called card. And let's grab this implementation and put it inside of here. So we're going to return this, but now instead of this.state.cards, we're going to pass it as props. What should we call it? Picture, emoji. Right? So now we're going to get the picture passed to us. So instead of this card here, we're going to say, here's a card whose picture is equal to this.state.card 0. And we self-close this. So we've done that right. Import card from card. Hey, cool. We've got an extra card because that's the same as this one, right? So this.state.cards 1, this.state.cards 2. Let's get rid of these. Cool, right? Slow refactorings. Extracted the card HTML into a component driven by props. Cool. So, right, what if I told you there were like 100 cards here? I wouldn't want to type all of those. So let's drive this using our friend. I want to turn this array into card components. Map. I'm going to turn this state array into cards. Map card. Right? I'm going to map this into a card whose picture is what? Just the card, right? Because I'm asking the state's cards to give me each card one at a time. So the picture is just the card. Return the card. What am I missing? This.state cards. Card is. Oh, this is a. Oh, and this is this. Cool. So now instead of these cards down here manually, I can just say, hey, put those cards that I just mapped inside of here instead. Now watch what happens if I take all of this and duplicate it. Right, now I have 6 cards. What's that?
Nice for the whole array.
Mm-hmm. Yeah. Right, I could just say let cards be symbols. Right? there's every symbol in our.
Right.
I would have to do something else in order to duplicate them. We're going to get to random cards in a minute. Now, still static cards, but generated via mapping over the state. Right? We're taking the state and we're using that to generate our cards. Right? Well, we don't want the card anymore to be. Right? We want all the cards to be flipped. We don't want to know what the card is. Right? We want the card to start out like this, and then we've got to click on it to reveal it. So let's see if we can get the card to have that click behavior and reveal itself. Right? So we need something else here. We need to have something else that says whether or not each card. You know what? First, let's do the solved part. Right? We need to know if the card is solved or unsolved. Right? Because if it's solved, we want it to look like this. And if it's unsolved, we want it to look like that. Right? So not only do we need to know whether or not this card is flipped, but we also need to know if we've solved that, we've matched that card. So our cards are going to become a little bit more complex because we now need something other than just a picture. So let's have it be an array of objects where we have maybe the picture being the emoji. And let's add another attribute to this object that's called solved, and that's going to be false. And we're just going to duplicate this a whole bunch of times. And I'm not going to use the others because I'm tired of copying and pasting emojis. And then we end our array. Right? So we change this a little bit. Now, this .state cards map card, we have to access the picture element out of the card. Right? Because our object in our array got a little more complex. Right? At first it was just the strings. Now the strings are stored inside of the object. So we're looping over an array of objects, and we're just picking out the card picture. Let's pass down solved as well. This card's solved. So now in card.js, the solved class is going to be if this props solved, the solved class is going to be equal to solved. Otherwise, the solved class is going to be equal to unsolved. We don't. So here, the solved class, when it gets defined here, will be undefined. And then we're going to assign it to one of these two things. So very temporarily between here and here, it will be undefined. But we're going to assign it to one of these two things. So you don't have to assign it to something. If you don't, it will be undefined. Now here, this class is a hard-coded string. Let's turn that into an interpolated string, kind of like you did the color picker. And here, let's just print out what the solved class is. And we got to wrap this in a JSX expression. And we've got to fix these class names. Okay, cool. They're still unsolved. But if we turn one of these true, right? So we're telling the system that that one's been solved. Right? So we can turn these over here. We can even do it inside of here. So if we come in and we find our React tools, and we find our card, and we say, hey, this card is solved. Cool. Solved, or not solved. Solved, or not solved. Cool. So we need another one here to track whether it's flipped or not. So let's start them all off as not flipped. And let's add commas. Let's do the same thing here. Let flipped class, if this dot props flipped, flipped class is flipped. Otherwise, the flipped class is going to be just blank. Right? Because I don't have a flipped and an unflipped, I don't think. I think I just have flipped. Yeah, there's just a class flipped. So instead of here, we'll say and then we said false here, right? So if it's kind of backwards. It's flipped over. Let's call it let's not call it flipped. Let's call it, no, it's not solved. So this thing will be true when it's hidden. Let's call it hidden. Let's call it hidden instead. That'll line up more with what we've got. So when it's hidden, it has nothing, and when it's not hidden, it's flipped over. Cool. So let me show you a shortcut, because Mike was asking about, like, why did we do this? So when we have code that looks like this, if some variable equals a thing, otherwise the same variable equals a thing, there's a shortcut we can use called the ternary, and it looks like this. This.props.hidden, question mark, empty, otherwise flipped. These two things are equivalent. A question mark colon, now I've got an equal sign. This is the same thing as that if-else statement. Right? So that means that instead of this, I can say let the solved class equal to this.props.solved. If that's solved, make the string solved. Otherwise, make it unsolved. It is. Right. This is called the ternary. If this props hidden is true, then flip class will be equal to this. Otherwise, colon, it'll be equal to this. And now that that's true, I can make these constant. Right, because I'm only assigning once. So this is equivalent to this, and this is equivalent to this. Right, so now I have something here where I can flip the cards over. So I need to know which card to turn over. So what I also need to know is where inside of this array is this card. Right? I need to pass down the position of this card. How am I going to figure out the position of this card? Yeah, so I could put 0, 1, 2, 3 in here. The other thing we can remember is that map gives us the card and an index. So map will give us both the card and where in the array it is. So I can pass down this index. So if we come into React Tools, we'll look now that we have a couple attributes. Let's look at our cards. Right? Card position 0, card position 1, card position 2, 3. So in our card, let's add a click. This dot handle click. And up here, handle click is a function that takes an event, and the event. And all we're going to do out of here so far is console.log this.props.position. Right, let's just log which thing we were clicked on. 0, 1, 2, 3, right? So we know where we're being clicked. Now what we need is a way to flip a card over, right? We want to be able to say, hey, when this thing gets clicked on, let's turn the card over. Let's make a method called flip card. It should take it's not going to take an event, it's going to take a position. Right? And let's just console.log, the app will flip, and it's going to flip position. Now what I need to do is I need to pass that function down to the card, so it's there for it to call it. So let's call flip card equals to this dot flip card. Let's call this handle what to do when clicked. What to do when clicked. So when you're clicked card, I want you to call the app's flip card. So here I can say this dot props dot what to do when clicked. Pass it this dot props dot position. Let's add a message here. The card says this props position, and the app is going to say the app will flip position. So now if we click on this one, the card says 1, the app will flip 1. The card says 2, the app will flip 2. The card says 3, the app will flip 3, so forth and so on. So now what we have to do is get that element from here and set the state. So this is going to be a little tricky. I don't want to show you array mutation just yet. So what we want to do now is we want to find the card, right? We want to find the card to be this dot state card's position. Right, we'll flip. Let's just log out the card that's going to flip. Right? The card will flip this one, the card will flip this one, or this one, or this one. Right? So here's what we're going to cheat a little bit. What we're going to do is we're going to say this dot state dot card's position. We're going to get that guy, and we're going to say its hidden is equal to false. Let's see if this will work. And we'll call this dot set state. Actually, let's do this. Const cards is this dot state dot cards. Let's just make a cards like this. All right, so we're going to take the cards from the state. We're going to find the nth card from that setup array of cards. So remember, our position is the index of the card that we're getting back from the card. Then we're going to say, go find that card. Let's go find that card. And finally, let's say that card's hidden state is going to be false. Then we're going to call set state. We're just going to give it the cards again. This changing the state of the component. This not set state is how we actually change the state. Well, here we're changing that card. We're changing the hidden. False, and it's not flipping over. Oh, we're not passing down. We're not passing down to the card hidden. Hidden is card hidden. So we weren't passing down the hidden state. So now that we do that, what? Why is this happening to us? Let's see if we can debug this. So if the card is hidden, what's the class on this? Nothing. So if it's hidden, it's flipped. And if it's not hidden, it's nothing. There we go. This is right. So let's see what happens when we click on this. There we go. click on them and then they turn over, right? Right, but there's nothing that's unturning them, and there's nothing yet that is only letting us turn over 2, and then checking to see if they're correct. But we now have some code here. The animation is done in CSS. Yeah, I'll post this little code pen that does it. It just does it with a transition, with a rotation. Did you write all that? I found an example that did mostly what I wanted to do, and then I changed it to do what I wanted. So I found an existing code pen that was like mostly what I wanted, and then redid it. So cool. We have now the card storing if it's solved, and if it's flipped. Then when we click on a card, we're calling what to do when clicked, and what to do when clicked is passed to us by the parent card. Cool. I'm going to pause here. Let's show you what the homework is and talk about the API. So you all can kind of read the API and get used to it. And then when we review it too, I'll finish the memory game where we can talk about how to start. No. Let's keep going. Because we have enough time, right? Because we go until noon. Yeah, so we got another hour. Let's keep going. Yeah, let's finish the game. Cool. So now what we want to do is we only want to allow there to be 2 cards turned over at once. So once we turn over a 3rd card, we don't want to allow that. So how are we going to know how many cards are flipped over? We want an if statement here. We want something that says, let number of cards hidden equal to something. Actually, we want let number of cards shown equal to something. Right? We want to compute how many cards are shown. So we want to go through this array, the state, right, and count how many cards are not hidden. So we want to go through an array and get back the cards that are not hidden. That sounds like filter. Right? We're going to go through an array and get back some of these things. So if we go through our this.state, let's just say this is revealed cards. This.state cards filter return, right? So this is our keep, right? Keep is something. We're going to keep any card whose hidden is what? Is false. Yep. So inside of here, let's console log revealed cards. Let's see what we get. Away. Clear. How many revealed cards are there? Right. 0. Sorry, 1. Yeah, it's card 0. Right. Now there are two revealed cards. Right. So if we click on it again, right, we don't want this to be revealed. We can say here, we could say, actually, we don't want to do this in the render. We want to do this in the flip card. We want to do it up here. It's too late after we've already rendered. Right? No cards are flipped. 1 card is flipped. 2 cards are flipped. So here we can say if revealed cards length, right, is greater than or equal to 2, return GTFO. Right? If there are 2 or more cards flipped, GTFO.
When did return take you back?
Wherever we called from. So in this case, it's from the actual click in the browser. What's calling us here is this card event here. So we would return to here, and then this would return to the browser. Because this is like our add event listener. It just ends this function. So now hopefully we click on one of these, we click on the second one of these, nothing happens when we click on the third one of these. Right? But we do want to do something if there are two cards selected, right? We want to do slightly different logic, right? So what is the logic that we want to do? If I flip over this, let's change our state a little bit. Let's put in because I don't want them all in there. Because I don't want to fill the user interface. Cool, I got a top hat and a whatever that is. Right, so there's that. And the picture is the top hat. Cool. So if I turn over this one, I get the popcorn. I turn over this one, and I get the robot. What am I looking to do? The gain is to match, right?
Right.
So if these two match, what's true? I go to solve. If these are true, these go to solve. So inside of here, we can say, let's call this check for match, and let's pass it the revealed cards. Let's make another function, check for matched. That's going to be a function that takes some revealed cards and does what? If revealed cards 0, picture is the same as revealed cards 1, picture. Let's just console.log. It's a match.
So it's smart enough to compare picture.
Oh, thank you. The picture is just some text.
Right.
It's an emoji. I could have used X and 0 or X and O's. It's a match.
If you put the empty array, would it? You made the empty array, would it still work?
Yeah, I'd never be able to win. And I'd have to say this check for match. Cool. So let's reveal this one. Here's our inspect. What's that? Yes. So if we do this and this, we don't get a match. If we do this one and this one, we also didn't get a match. Let's console log. That's what we're going to debug and find out. We expected to, and it didn't. Let's see what happens. So I click this one, and I click this one. Oh, because I'm only doing it if there's more than 2. I want to do that down here. I don't want to do it when there's more than 2. I want to do it when there's not more than 2. Right? When there's more than 2, I want to leave. I want to just after I check for 2. So here's this card. What? Whoa, 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 whoa. Stop going. Something broke. What broke? Reload. Check the window app. That's fine. We're going to talk about that in a minute. Cannot read property length. Oh, because this has to stay up here. It's the call to check for a match that moves, not the whole thing. I want to ask how many revealed cards there were, return if there are more than 2. Otherwise, I want to check for a match. So let's see if this now works. Nope. Let's not check for match. Cannot read property picture of undefined. Ah, okay. So we only want to do this if revealed cards length is equal to 2. If there are 2 revealed cards, check for a match. If there's more than 2, return. If there's exactly 2, check for reveal. Logic. See what happens when I don't write it out at a time?
Let's see, we're saying if revealed card 0 dot picture is equal to revealed card 1 dot picture, it's a match. And the top one not being revealed card 1.
So here's the deal. here's the deal. So when this is being clicked, I'm about to turn this one over. So one of them, so when I do this, now revealed cards will only be one. This is the card I'm flipping over. So we're going to change this logic a little bit. No. So here's what's going on. When I'm about to click on this, let's console log this out so we can see what it is. Let's console log the revealed cards. So I click on this, there are no revealed cards. Right. So when I click on the second one, I have one revealed card and I have one card. Let's console log the revealed cards and my card. We're going to get rid of this for a second. Right? So I click on this. My revealed cards are blank, and this is my card. I click on this one. My revealed cards is the one I already flipped over plus me. We're going to have to change this function a little bit. So if the revealed cards, this stays up here, Gavin. Stop moving it around. If the revealed cards length is exactly 1, then let's call this dot, what do we call it? Check for match. What we should pass it is revealed card 0, that's our revealed card, and my card. So this is the card that's already been revealed. And then this is the card I just clicked on. So up here, what we can say here is first card and second card. And then we can say first card, and here we can say second card. Right, this is the card, we're flipping over one card. We can say if there's already 2 revealed cards, then get out. Otherwise, get my card, make it visible, and then check to see if I had one card revealed, I'm the second card that's being revealed. So pass, check for match, the first card being the first element of what's already been revealed, and me. So this should work. So here's my first card. There's my second card, it's a match. Right. If I reload this again, I click on this, the popcorn, and the robot, I get nothing. Cool. So now this means that up here what I can say is I can say the first card, what did I call it? Solved is true, and the second card, solved, is true. And then I can say this dot set state my cards this state cards. I'm cheating here a little bit. We're going to talk about why this is bad in a second. Sorry, what's that? Oh, solved. Yeah, but the first one didn't change. You should have seen this card, and this card. Oh, and what we want to do is we want to unflip them. Hidden and hidden is true. We want them to be solved, and we want to turn them back over. So this one, and this one, let me turn back over. This one, and this one, they don't match. So, regardless of whether or not they match, right? Regardless of whether or not they match, we want to set they're hidden. So this one and this one, we turn them back over, but it's happening right away, right? So what we can do, yeah, down here we can say set a timeout, because we want it to happen once. Set a timeout with a function.
Set interval is like for a looping thing where it happens once.
Yes. And let's give it like a second. So now we'll only check for a match after about a second. Let's see if that's enough time. This one and this one. Yeah, maybe 2 seconds. This one and this one.
Awesome.
This one and this one. Right. But look at that. Oh man, I can still turn one over. Right? So what do I have to do here is I have to say here.
Since you can turn it over, if you were to click one of the unsolved ones now, will that switch back?
Yeah, it will. If the card solved, return. If the card is already solved, GTFO. Right, so now hopefully, if I turn this card over and this card over, I can't turn it over anymore. Turn this over, turn this over, and it goes back. All right, and we have the basics of a game. Let's talk about some of these errors we're getting here in the console, because you've seen some of these. So we're getting a warning that each child in an array or iterator should have a unique key. So when we talked about the rendering lifecycle, we said that every time state change our apps re-renders. What happens in React is it actually re-renders that render into like a shadow copy. It makes an internal copy of that new DOM, and then compares it to what's on the page, and it only updates the part that had changed. We can actually see that if we turn on this feature. So if you're anywhere in the developer tools and you hit the escape, this will pop up, and if you click over on rendering, let me make this smaller so you can see what it looks like normally. Right? You hit escape, this will normally pop up, something that looks like this. If you click on rendering and turn on paint flashing, what will happen is anything that's being re-rendered will flash. See how like the screen is flashing because it's re-rendering all of that? If I click on this, I'm not seeing any kind of, oh, there we go. Let's see if that, get a flash. Yeah, I don't think we're seeing the flash because of the animation. Try this again. Click. Okay, that didn't really show what I wanted it to show. Did that kind of flash green when it was flipping back over?
It only calls the backs of those cards if it's true. The other one's already in the DOM, right? So it's not changing?
Yeah, but it's changing the class, so it should be refreshing. The idea is you would, like if you brought up your crypto tracker, right, and you turn plain flashing on, you would only see the coins where the price is changing. But here's the deal. In order for React to be able to do that intelligently, it needs to know when I'm re-rendering this card, or I'm re-rendering this octocat, or I'm re-rendering this coin, is it the same coin I rendered before? Right? So what it's complaining about is like when you do this thing with a map, it doesn't know which card is this card, right? And all it sees is an array of cards. When we laid them out in the DOM ourselves manually, we were kind of declaring the order they were in. It can't know. So every component has an attribute that we don't use, but we give to React that says, hey, what's the unique key for this card? How do you tell this card from all the other cards? All right? So we already have an index that tells us where this card is. Let's just tell React, hey, your unique key is index. Right? Using the index of a for each or a map is a pretty common key because it only has to be unique to its siblings. right? So this key is 0. If the card then iterated over something, we could use index 0 there again. Those are different zeros. This is the 0 on the card, this is the 0 on each child. So we just have to give each card its own unique thing, and then we'll get rid of this error in our console. Right. The only last error is that we're not using this logo.
How did you get that thing off where you could select like paint, whatever?
It is if you hit escape, and then you can turn on and off paint flashing.
It does not happen.
In Chrome?
Opens the console.
So you have to have the app open inside Developer Tools, and then hitting escape should bring that up.
It's bringing that up, but the only, like where you have the 4 options there, the only one that I have is console.
I'll have to see why you don't have it.
Okay.
It should be there. So let's see if we get the paint flashing. No, we still don't. It's probably because of the animation. Oh, we kind of saw it there.
Oh.
We kind of saw it really briefly.
I figured it out.
Okay. So you're going to get that error about having items not being unique. What you're going to want to do is, how come I can't class that anymore? What you're going to want to do is every time you do a map or for each and you're generating components, just give it a key that's the index. And that will help React know where things are.
You ever use the key?
No, so you can't get at the key in the properties. So if you want to know where it is, you see how we repeat index?
Yep.
We just give it back in its position. All right. So let's generate our state randomly. So let's say on component will mount. Let's generate the things randomly. So let's generate a random number. So we do math.random times times 50, right? And then we can call math.floor. Cool. So just remind myself how you generate random numbers. Floor rounds it down. So what we want to do now is we want to generate some number of these at random, right? And here's how we generate a random number. So when we mount, what we want to do is not have these pre-filled in. We want to pick these randomly from our symbols. So we're going to use a for loop. Let's say count. Count to 0. Count. Listen, how many do we want to put on the board?
12.
Was that?
12.
12. So let's let the random index be equal to. So it's not 50, it's how many cards there are. So that's in symbols length. Let's say cards push. Let cards be an empty array. And then let's say cards push, the picture is going to be what? It's going to be symbols access random index. So there's our picture. Our solve is false, and our hidden is true. And then when we're done, this dot set state, cards are cards.
You're only going to have one set of items.
Every time, I call this new cards just to be clear. Right? When we mount, we're making a new cards be an empty array. We're doing a loop up to 12. So count will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. We're saying, give me a random number between 0 and 1, multiply that by how many symbols I have, and just chop off the decimal part. Right, so that'll give me a random number between 0 and how many symbols I have. So that's the index into my symbols, random.
How does that affect the top number?
How does it affect what?
The 50 or whatever the top number is.
Because if you...
It's less likely to hit 50?
Yeah, there's better random number generators than this. This is the quick and cheap one. Oh, I don't have symbols. So like times 50. Since 50 is the length, that's one more than the index, right? So the last index is 49. So I will be able to get a 49 out of this. Yep, there's a 49 right there. But it does have some favoring of numbers because of the way we take the random and multiply it. But it will get the last one.
So is it generating a pair for each symbol?
You're always running down to how they
It won't get 50. So here's an array of 5 things. Index 0, index 1, index 2, index 3, index 4. I'm never going to use index 5. So I'm never going to use index of the length, right? This is the old off by 1, right? So my indexes start at 0, and they go up to length minus 1. So this will be fine, right? Because I'll never get symbol length, but that would be off the end of my array anyway. So here's what's happening. I'm making a new cards array that's blank. I'm going to do this loop 12 times. This is our old friend for loop. I'm going to do this loop 12 times. The first time through count's going to be 0. I'm going to get a random index by taking a random number times the length and flooring it. This is kind of our boilerplate for generating a random number between 0 and up to, but not including the length of my symbols. I'm going to take new cards and push to the end of it a new object whose picture is symbols index my random index. Solved is false, hidden is true. And now you see, if I look in React,
It doesn't generate random pairs, does it?
no, I don't know if it has random pairs.
Could it be,
Mhm.
and can't you get 2 of the same? Or 3 of the same?
Yeah. There's an eye, and there's a running person. Right. There's a flower, right, and there's a, right? So if I wanted to generate pairs, what I'd have to do is push 2 of them and then shuffle them, right? I could push the same thing twice, right? So now I know that I would, but I also know that like, this is gonna be the feet, and that's gonna be the feet. Right? They're right next to each other. So now I gotta shuffle them. Let's find one of your github.com. This is in your blackjack. Your blackjack code has a shuffle in it.
Can't you still pull 2 sets? Like, how does it know that you're going to already use an emoji?
Because that's the symbol's random index.
What if it pulls the same random index twice?
I can have doubles of them. That's fine. I mean, I can have 2 sets of flowers.
So then you have 4 flowers.
Right. That's fine.
So it makes it
all the
easy.
cards to do the for each, right?
Yes, if I was using all the symbols, I could use a for each loop. So let's start this at new cards.length. This is new cards I, new cards J. This is just borrowing our deck shuffle from blackjack, and now these should be randomized.
Why don't you put it in the middle of your card shuffle?
Because I want to push pairs and then shuffle once at the end.
They only match if both of them have been flipped over at the same time.
Yes.
So you have like 2 sets.
Yep.
Same ones, right?
Yep. Pick a random number between 0 and the number of symbols. Push that symbol based card twice, so there are pairs. Shuffle. So we can cheat, right? Because we can look in React and like see where the pairs are. Okay, so, oh, here's a cookie. There's a cookie right next to it. Cool. So where's the cookie? It's right here and here. There's a cookie, and there's a cookie. Of course I would. So that's a lollipop. Oh, snap. That was lucky. A tree. Oh, wait, look there. A lollipop. Oh, where was that lollipop? I already got one, so I got a double lollipop. This is the very first one.
Yeah, the plant one. Oh, no. I was the last big one.
Go in there.
I was recording when I did that.
Yeah. So here's the basics of the memory game.
Pretty cool.
Yeah. So the one thing that we're doing that's kind of illegal, is we're not supposed to mutate the state that we have. So this first card and second card are actually coming from the state. Like this, like calling cards and passing cards itself is kind of a bad habit. What you're gonna have in your Minesweeper is you're not going to be mutating anything because the API is going to do that work for you. So the way that we have to do this is we essentially have to duplicate the array. So we have to take our cards array and duplicate it and change the duplicate and assign that duplicated thing back in. Do you have enough time to do that? Yes. MBN array duplicate. So the way we're supposed to do this is this. It's called slice. Yeah, this is how you do it. So this is what I didn't want to show you all. So what you end up doing is you do something like this. Let new cards equal to cards dot slice, and you slice from 0 to cards length -1. What you end up doing is duplicate the cards, right? And then what you end up saying is new cards of position, set that hidden equal to false, and set card equal to new cards, right? And this gets kind of weird. I should still be able to turn these over, right? Oh, snap. Right? So this is weird, right? Because one of the things about React is that state should be immutable. Right? We should not change the state directly. The only way you're allowed to change the state is calling set state. So if I go in and tweak an object that I got back from the state, right, and I try and call set state again, weird bugs can happen. What we're going to learn in a little bit when we start talking about Redux and a couple other things is there are ways of saying, hey, state that's an array, I want you to go and find the 4th object and change it to this. Right? Because set state has to take the entire cards array as one thing. So we need to produce a new copy of it and give it the entire array each time. So there are things we can do to say, hey state, I know you have a cards, and cards is an array. I want to give you a new object. I want you to go into the cards array and find the 4th element and just replace this one. So this is a little bit of a cheat. This is without that tool. This is the right way of doing it. You make a duplication by taking the entire slice of the array and gives you a new copy, and we change that copy and we send the copy back into state. That you don't have to worry about, because for tonight, the API is going to give you data every time that's new. So you're never going to be mutating state. You're going to be getting some information, mutating something, sending that to the API is going to give you back new data.
The API is going to choose where the mines go and things like that.
Yeah, so it's gonna make the board. It's gonna do all the randomization. All that's gonna come from. It's all gonna come from.
Why did it sit there at the bottom?
I think because while it's rotating, it's changing the flexbox nature. I think that's what's going on. Cool. Let's talk about tonight's homework. And let's go over let's go over the. This is your weekend homework. Minesweeper. Oh, really? Curriculum, frameworks, React Part 1, assignments. You find it this way. Minesweeper. Cool. You're going to communicate with a backend API server to create the user interface for a Minesweeper clone. So the backend is already created for you, right? Suncoast Developers Guild provides that for you. If you've never played Minesweeper, right, like learn how.
We are going to look at how to.
Or you can like find a Minesweeper clone, or just play Minesweeper if you already have it. So we're going to learn and reinforce how state drives changes to an interface, respond to user events, understand and use APIs. You're definitely going to need the lifecycle methods. You're going to have to understand and read API documentation, and use fetch to perform a post request. So far, we've only ever done fetch requests that are gets. So we haven't talked about the fact that when you go to a web page and you put in a URL, something else goes along with that URL, which is the type of request it is. And we call that a get request. Hey web page, I want to get that HTML. Hey web page, I want to get that image. When we submit a form, we're not getting information, we're giving information. Right? We're filling in a form where we're giving the server some information. That's a post request. So we're posting information to the server. Right? You can't do a post request in your browser, right? Just in the URL bar. Those are always gets. Posts are things like forms, or when you do a JavaScript request with fetch, you can tell fetch, this is not a get, this is a post. And we call those HTTP verbs. Right? I'm posting this data to a URL, I'm getting this from. There's get, post, put, patch, delete, head, info, options. There's like a dozen or so different verbs. The most you're going to use are get, post, put, patch, and delete. Right? And
Fetch.
nope. So fetch is the library that you use. The verb is get. That's the default verb. If you say use the fetch library to give me this URL, you're using a get. So fetch is the library. The URL is the HTTP : API CoinMarketCap. Get is the verb. What kind of work are you doing? I'm getting this URL. That's the default. But there's also post saying I'm sending you information. So get gets information. Post will put information and optionally get something back in return. So you're going to have to do a little bit of research and find out about post requests. So here's the app we're going to use. It's Minesweeper API Roku app. If we go to this page, we're going to get all the documentation for it once it wakes up. So here's the documentation. So it says, this is Minesweeper. It's a description of the Minesweeper clone API. Over on the left, it shows you all of the URLs that you can generate and give to this API. So there's 4 different URLs you're going to be using. Let's look at this and see how this works. So here is a resource. This is an action we can call on the API. If we ask for post and we give it the URL /games, so this is putting /games on the end here, /games, but it has to be a post, which we can't do in our browser. There are some parameters that we send it. Right? The first parameter we send it is called difficulty, and it's going to be a number, 0, 1, or 2, which determines how many mines there will be. Right? An 8x8 with 10 mines, 16x16 with 40 mines, XRO 24x24 with 99 mines. The next thing we can do, and the response is going to be a 201, and this is what the response is going to look like. So the response is going to be this, the ID of the game and the board. And the board is what kind of thing? and each element of the array is another array. So this is an array that contains arrays, a two-dimensional array. So this is going to be the board, a row of the board, a row of the board, a row of the board. And you see they all start out as blank. So this is a new game. So it's going to give us an ID and a board. Now, if we ask for get games and an ID, that will retrieve an already created game. So if we post to/games, we're going to get back some JSON. One of the elements of that JSON is the ID of this game. Right? It's going to tell it's a new game, there's 10 mines, and its ID is 1. If we ask for games 1, that will retrieve the already created game. The state will be one of new, playing, won, or lost, and these are what the cell values can be. An empty space is unrevealed, an underscore is an empty revealed cell, an F is a flagged cell, a star is a cell with a bomb in it, which is shown only when the game is won or lost. An @ symbol means a flagged cell with a bomb in it, only shown after a game is won or lost. And 1 through 8 is the number of neighboring cells that contain a mine. Right? So what do we pass it? We pass it the number, right? That's up here, the ID. What do we get back if we show this? Hey, doesn't that look just like the same board again? Right? And look, you can see that there are some like numbers and there are some things that have already been clicked. Right? This is what the body will look like if we ask for a game. The next thing we can do is we can check a square on the board. So if we post the URL games and then the ID for our game and check, we will be checking something on the board. The parameters we need to give it are row and column. I'm going to give it the row number, row 5, and they're clicking on column 7. And if we do that, we get back, oh my god, it's the same thing again. It's just the ID and the board again, right? And the state and the mines. Where do you think you're going to shove this response? When you get it back, where do you think this kind of response goes in your app? Think crypto tracker. Where did you take the data that came back from crypto tracker? You put it in your, you all know this. Come on, just say some, we're saying some words.
The return.
No, the state.
The state.
This is going to go in the state. This is the state of your app.
Oh, right, okay.
This is going to be, the state of my app is I'm playing board ID 1, and the board is this. And the state of my game is that the state is playing. And the state of my thing is that I have 9 mines. So every time we get or post to this thing, we're getting back essentially the state of our game. So when we fetch this from the API, the response is going to go into the state. Just like crypto tracker, you made a request for the coins, you got back data, you put that data in your state, your game re-rendered. We're going to make a request to this Minesweeper API. It's going to give us back a whole bunch of data. We're going to put that data in our state. We're going to re-render the display of the game. Guess what? Flagging a square works exactly the same way. We call post to games ID flag. We give it a row and a column, and we get back, holy crap, it's the same thing again. Right? This looks like the state of my game. It tells me what squares have numbers, what squares have flags, so forth and so on. So let me show you a tool that will be helpful for you to play around with this API. It's called Postman. So Postman is a tool that lets us work with APIs in a really neat way. So you're going to download Postman. Here it is. It's downloading. Hopefully I can get to it before you all swamp them with traffic. So you're going to download Postman. And I'm going to add it to my applications. So if you launch Postman, what you'll get is this nice interface we can start playing with APIs. So here is a view of Postman. Up here is that verb. Hey, we're going to get, post, put, patch, delete, copy, head, options, link, unlink, purge, lock, unlock, pop, find, and view. Whew. All you really have ever heard of is get. So let's go find that API endpoint for Crypto Tracker. Where was that? That was back in last night's homework. And Crypto Ticker. Right, we said this was the API. So if we put this here as the URL and we send it, down here in the bottom, we get back, right, the body of our response, and it tells us that it's JSON. Right? Here's our response from Crypto Tracker. Right? Old familiar stuff. Right? We just used to put this in the browser, right, and we would see it in our system. But tonight, for our game, in order for us to really get going, how do we start? We've got to have something where we can create a new game, right? So, and we see that that's post. So in Postman, if we say, hey, we're going to post something, right? What's the endpoint? /games. It goes to this /games, right? But we have to send it some parameters, right? So up here in our parameters, what did it say our parameters were? Difficulty, which is a number that's 0, 1, or 2. So what do you want to make, an easy, intermediate, or an expert?
1.
Let's make it an intermediate. 1. And if I send this request now, it's a post request to this API with a difficulty parameter of 1. I should get back, hey, look at that. It's a new board. What game number are we playing? 8,304, and there's our board. Cool. Let's now make a new API request.
Does this API generate the game keys like sequentially?
Yes.
Like that's how many games have been played?
Yes, 8,304 games have been played. So let's grab this URL again, and let's make a new tab, and let's get that game. So we just made a game. We should be able to get that game, right? So that get is /games and the ID. So this is a get, right? And it's games /8304, right? That's what we said. 8304. Let's get, hey, there we are. We just have an empty board. Let's make another tab where we're going to check a square. So here's how we check a square. We say games ID check. It's going to be a post. The parameters are what? The ID, well, that's already here. So we need to specify that again. What's the next thing? The row. So which row do we want to click on? 7. And the other thing is call. What column do we want to check on? 7. Let's send this post request to game 8304.
You can blow up.
All right, we didn't blow up, but a whole bunch of things got checked.
You probably opened a bunch of squares.
We opened up a whole bunch of squares. So if we took this response and just rendered it on the screen in a nice way, right, we would have just played the first step of a Minesweeper game, right? So there's going to be some on clicks. There's going to be some on context menus for right clicking, right? So we could also flag a square by doing almost the same thing. That's the entire API.
So we're going to be using Git and Post to actually manipulate our interface every time some event happens.
Yeah. So just like we did tic-tac-toe, what do you think the first thing you're going to do is? Statically build out an 8x8 Minesweeper board, right? Right, with all of them being blank. Then you're going to build a state, right? And guess what? You don't even have to decide what the state is because this is your state, right? Here it's already telling you in the API that a new empty game board looks like this. So what should your, when you do that, like, hey, I'm going to take it from being hard-coded to being driven by a static state, what do you think you're going to type into that state? Just like this, right? And then change your board to use that this.state, right? Then make a component for a square. Send it props. Flow it the same way we flowed tic-tac-toe. Right? It's the same flow, but rather than when someone clicks on a square, having to know, am I X or am I O, right? What you're going to do is when you get that click for a left click, what API endpoint are you going to go for? Yeah, you're going to say, you're going to call check, right? And what are you going to pass it? The row and column where they clicked, right? So what do you think some of your properties of your Minesweeper square are going to be? Row and column, right? Yeah. And when you do that, right, you're going to fire off a fetch that's a post to whatever the URL is for your game number / check. You're going to get back a new state. You're going to replace your state. Your game is going to re-render. Yeah. So you're probably not going to want to keep that being a manually generated square, 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 right? Do you have an array here? Yeah. And what do we know to do with arrays when we want to turn an array into an equal number of things like Minesweeper squares? Map. Right? So it's going to be pretty similar to the tic-tac-toe demo we did today, right? So you're going to be practicing state, props, map, fetch, sending event handlers from a parent app component down to a square component that calls back. All of these things are going to come together. What I suggest you work on today is building a, let's see, I would probably have you all build at least an 8x8 or maybe a 16x16 static version of your Minesweeper game. Build a 16x16 static version of your Minesweeper game and get it all pretty the way you want, right? Make it look like a Minesweeper game. Then do the step where we did in tic-tac-toe, where we made a state. Use your state. And then have each of those squares represented by this.state.board, something to get this square, then this square, then this square, then this square. That will render you an empty Minesweeper board. Then change one of these to one of the values that we know it is, either an underscore, an F, a star, an at, or a number, and see if your board will represent a state that has bombs and flags and numbers in it. Once you've done that, right, you know that you can change the state and have your user interface reflect, just like we did in tic-tac-toe. Hook it up to this empty game API. Rather than you hard coding that state, just have it fetch it by having post to games, right? Then what you can do is you can use Postman to pretend like you're making moves, just like I did. So if you post to game 8304, right, and then we went into Postman and we said check row 7 and 7, what would happen if you were just to like refresh your user interface, right? Right. If you then fetched this API and rendered it, right, you would see this. Before you even get to the point of being able to click or right-click or anything, if you have something in your app that gets the game and replaces the state, you can use Postman to simulate playing the game before you even hook it up to anything that's in your app. That's my recommended flow. So today, like in the afternoon, get your Minesweeper HTML and CSS going, right? And then see if you can get to the point where you're rendering that static HTML and CSS from a statically typed in state, right? Like this.
We want
Right.
to go just an 8x8 HTML.
Yeah, I would probably start with an 8x8, right? But very soon you're going to get rid of that static hard-coded and use map. Kind of like I started with the cars where I just had like 3 or 4 cars, and then I built up an array and I mapped. you're going to want to do that pretty early, right? So by like review it 2 times, if you're going to have your HTML and CSS done and start building that empty state and using map to build your square components, that's a good spot for them. Cool? Right? This is going to bring in kind of everything we've learned this week together. Trust me that if you start with that static mockup and you slowly march through, but kind of follow the flow we did for tic-tac-toe and for memory, right? It will not be so overwhelming. And then using Postman behind the scenes to simulate, right, the API and making moves and just see if your user interface can like refetch that will tell you that when you get to the point of clicking and sending it the right request that everything is working. Cool? Yeah. I know you all have this because like you were really kicking butt on the color picker, right? Like that was a good challenge and you all did really, really well on that. So I trust that like this seems daunting and the stuff we did today seems daunting. If you just slowly plow through it, right, step by step, you'll get there. Right? You've got the whole weekend to work on it too.
We will be.
Yeah. Cool.